Okay, welcome to the electrical engineering course. And some of you will take the different course name, right? Electric and circuit, right? So something like that. Okay. But we will study together. And the grading system will be the same system. Okay. And tomorrow the team will show you uh, how we manage the score in between theory and lecture. Okay. So my name is Kirati, Ajahn Kirati Chiakunkiri from the School of Electrical Engineering. My room number is CHE18. I am with the School of Electrical Engineering, but my room is not EE, CHE, Chemical School of Chemical Engineering, in the zone of chemical engineering. Because the EE school have no room for me. It's full. The room is full. So I asked chemical engineering school, but they have some empty room. Okay. In the fourth floor of C1 building, and this is my email, and this is the telephone. Okay, but we can communicate by Facebook group, maybe more convenient for you, right? You can send me email also. Okay, this is the content of this course, electrical engineering, and we will learn about the general principle of electrical engineering. So, and remind you again about DC and AC circuit. Right? You know DC and you know AC circuit, right? And we learn about magnetic circuit. This is maybe a bit new for you, right? And the transformer, electric machine, electronic device, which are diode and transistor, and the circuit, the logic gate, and digital IC and control system. So many things. Okay, it's too much. I think it's too much. Because for electrical engineering, we learn this one semester. Magnetic circuit and transformer and machine, this is another course for us. Electronic circuit, another course for us. Logic gate and digital is another course. Control system is also another course. This is 1, 2, 3, 4, 5. In electrical engineering school, we learn circuit one term. We learn transformer and machine one term, one semester, and electronic device another one course for us. So we go into deeper, okay? And logic gate and digital IC, digital circuit also another one course. Control system, one course. For mechanical, you will have control system course, right? It's like same thing, right? To go to deeper, right? So, but your curriculum design, they would like you to learn everything. Okay, that's it. So we go to overview, not going to very deep, right? Just to get some background, a basic idea for you, and it's good for you if you do go into deeper in the future. Okay, so I just can do like this because we have only 2 hours a week, right? Okay, 2 hours. So after this class, after 10 o'clock, do you have any class? No? Any of you have class? Oh, you want to go back to sleep. Okay, so you have no class. Yeah, it's good that if we need some more time, okay, or we may have some make up class. Okay, if we use this Thursday, right? Thursday 10 o'clock may be a good time for make up class, right? Okay? Okay. Just for some week, right? Okay. Just for the week that we need to make up. If we cancel some class next week, we may use this time. Okay. It's good. Okay. Okay, this is the content that I divide into the main content. So first we talk about general and principle of electrical engineering. I think this is maybe we can go in today, right? We can finish it today. Then next time we get into AC and DC circuit. In fact, this is we have to learn about the Kirchhoff law, right? KCL, KVL. You know about this in physics. Kirchhoff laws, right? And Ohm's laws, right? And we will do node analysis and mesh analysis. And then Thevenin and Norton theorem. It is. And we will do something on transient circuit, AC circuit, and transient circuit. So this part, I need at least 2 weeks, right, to cover this. Okay, this is the good background for you. And then magnetic and transformer, maybe magnetic and transformer also another 2 weeks. Electronic device you will learn op amp. Sorry. Op amp. Diode, right? Diode. And transistor. So you know what is diode, what is transistor. Right? And I think the midterm should be around here. Then the logic gate and digital this is okay. The logic gate and digital IC. Maybe 1 week. Okay. This is digital and control system would be here. Electrical machine it will be merged with this. Right? It's magnetic circuit and transformer. DC and AC. This is we talk about motor and generator. Okay, motor, generator. So it should be just like this. Enough. This okay? It's not too much. Okay? I think it's too much. I thought with your teacher in your school, I said that it's not possible to do this. It's not possible, and she says, I want this. So I just follow. So I just follow because this is from the curriculum designer, right? So the teacher just follow this, and this is which one is hard and soft. Okay, we go deep into just into some topic. Okay, this is the tentative for lecture class. Homework, quiz, and assignment assigned for you. And this is midterm, and this is final, and you pass if you get 40%. 40% is okay. And last year, nobody failed this course. Nobody failed this course last year. It's good. I want you to pass all. Okay? At least D and above. Okay. So please do the homework, quiz, and assignment, so you get 15. Okay, that's it. In fact, last year your senior, one of your seniors, get 38. 38. In fact, only one. Awesome. But I think too much. So I hope all of you pass because it's difficult to manage because you're a small group, right? You're a small group, so it's not 100 students. 20 students fail, we can arrange the cost for it, right? For 20 students. But if only one of you fail, it's very difficult to arrange the class for you. And it's not funny for you also to study alone, right? Go to the lab alone, come to the class alone. Right? In that case, maybe I use my office as a classroom sometimes to deal with the two very small group of students, maybe only one or two students. So we avoid to get that situation, right? Okay. So please come to class, study hard. So at least you need only 40. So, okay. Okay, this is the class material, and Facebook is the own link. Do not follow this link. You just follow the link in the Facebook group. Okay. Okay, and this is a textbook. Okay, it's the reference textbook, and this is the contents. Okay, of the textbook, and you can see that is also matched with your course. Okay. Fundamental of Electrical Engineering, Recessive Network, AC Network, and this is recessive network, this is DC, and this is AC network, and this is tangent analysis. We also touch on tangent analysis, and AC power, and then this is op-amp, right? Op-amp, semiconductor and diode, and transistor, okay, and digital logic circuit, electromechanic. This is a machine like this. It's fine for these rules. Okay. Okay, so I will go to some introduction to electrical engineering. So, and you are not electrical engineer, but you need to know some much about electrical engineering, also programming. Also. And people know about the electricity or the charge on early 16th century, right? Yeah. And we can generate the electricity in about 18th century. So we know how to produce the battery. Then after that, about 30 years later, the Faraday discovered the electromagnetic induction. We know that we can generate electricity by electromagnetic phenomenon like this. This is you also learn in your physics course, right? Then after that, a very long time, right, for about 40 years, we know about electromagnetic theory. So to prove, to relate to this theory by Maxwell, okay, by J. Maxwell. So this is a strong relation between electricity and electromagnetic and magnetic field. This can come in together. Yeah. This is a good knowledge to study about engineering technology. Okay. Then the real utilization of electricity started in 1878 after Edison invented bulb, right? Lamp bulb, right? He supplied the electricity to the town, and for lighting purpose first at that time. This is the first practical use of electricity at that time. So that time, people use DC electricity, DC system, and Edison sell a lot of lamp bulb, incandescent lamp. The incandescent lamp will generate the heat. There is look like this. There is a filament of the lamp, and when you get the current into the resistance, it will take the heat, and it's not burned because inside there is no oxygen to burn, right? This is the vacuum tube, in the vacuum tube, and it will generate the heat, but it's not burned. It will turn into the light. Okay. But there is so many limitations of DC circuit. The DC circuit, we can transmit the electricity at that time in short distance, okay, not in the long distance. And then after that, Westinghouse invented the AC system, the electric AC system. And in AC system, we can transmit the electricity in the longer distance with the help of equipment known as transformer. Okay, and in AC system, when we generate in DC system, for example, at that time we generate the electricity by battery. It will get into not a very long distance, and in AC system, when we generate electricity, we can step up by transformer. This is low voltage, right? Here this is low voltage, so it cannot transmit too long distance to transformer, and we step up into high voltage. We can get into the long term, and we get another transformer to step down to low voltage. This is the advantage of AC system, right? Transformer is like this, V1 and V2. The transformer which you learn in physics, you learn about transformer, right? If you have number of turn N1 and N2, what is the relation? V1 by V2 equal to N1. Do you remember this, right? You can step up the voltage and send it to the long distance. Then you step down. It's because step up, and this is step down, and come to the home right in low voltage. So it's made AC system become common use this day. Okay, so in here in this building we also use AC system, right? Because we transmit the electricity from a very long power plant, right? Very far power plant, right? Come to this building. Okay. And this is a very large network. To step up the voltage, we can transmit if you for common formula. P is V into I, right? This is also P is V into I. If you transmit the power with the low voltage, you need the high current, right? If you want to send high power, the large amount of power, if your voltage is low, it's no choice. The current will be very large. Okay? You will need a big conductor. Okay, very big wire. And there is a lot of loss in that wire. Okay? And at the end of your wire, there's almost loss in this wire, and in the end of the wire, you get maybe the power is lost in between the line. Okay? That's why you need very large conductor. But in AC system, when we can step up, we step up the voltage. In this case, if the voltage we can make it high, then the current will be lower for the same power, right? For the same power. So you can send large power to the network. Okay? And this is the advantage of AC system. Okay. So, Westinghouse sell a lot of product with AC system. That's how it's become common use today. But right now, with this today technology, we have the technology known as power electronic. That can convert DC to DC, DC to AC, AC to DC, AC to AC. This is a very good technology. So we can convert DC to high volt, AC to low volt, just like that. And most of the equipment today, in your home use DC. In fact, for example, our mobile phone. This is DC, right? This is DC. You need some switching power supply to convert AC to DC. In fact, this monitor use DC. We also need power supply to convert to DC. Computer also. Projector also. We need DC power supply. And a lamp. Most of the lamp today not in this room. This is the old version, right? Of fluorescent lamp. But mostly today, if you go to the shop, you will get only LED, right? LED lamp, which is DC circuit. Okay, so most of circuit at the end use we use DC right now. So there is some technology that try to transmit power in DC now. Okay, in DC grid, DC power grid is also possible in the future. We back to DC in the future, or mix AC and DC in our life. Okay, you see, maybe if you go to work as an engineer in your factory, or maybe in the industrial park, you get you will face with both AC and DC equipment. Okay. Okay, after that, you can see this is in 18th century, and after that, we start utilize electricity in many forms, not only power, not only for lighting, not only for driving. So we also use electricity in other way, maybe in small signal, right? For example, radio signal. Also, we use the signal of electromagnetic. And then we start using computer in 1941, right? This is computer, and the first computer is very large. We use Arc tube, and then after that, people invent the transistor here in 1947 that can scale down the size of computer, of the computation system. Okay. Known as transistor. And many transistors compressed into one single chip we call IC, integrated circuit. Can have integrated circuit to one single chip. This is a lot of transistors compressed into one single circuit. But in the lab, you get this transistor, right? One transistor. You can imagine that in your mobile phone, there's a lot of transistors, right? In the circuit, in a single circuit. Okay, we go. Okay, yeah, integrated circuit. There's a lot of transistors into one. And then we develop microprocessor. With the controller. Okay. So there is a lot of utilization of electricity in many ways. Okay. So in electrical engineering, we also can divide into sub area. Okay, for example, power engineering. I am power engineer, right? I use my research and my knowledge is about power electric, okay, to use this as power machinery. So I am not expert in electronic circuit. Okay. Yeah. power theory. We study about how to transmit the power. So, okay, to use the power, how to storage, energy storage, distribution, transmission, generation, how to generate it. Okay, for the last system. Control system. Okay. Control system is design dynamic system control. Right? Is some engineer, also expert, especially on control system. Okay, to use the signal of electricity for control, right? Sensor, okay, control command, for example, and electronic, right? So here we also have electronic engineering in separate school, right? So you can see that we have electronic engineering school is separate from electrical engineering school. Study about design of IC microprocessor. Yes. But for electrical engineering, we also need to learn electronic and control system also. Signal processing. Okay. To analyze this about the signal. Telecommunication. Transmission system voice or data communication. Okay. To use the electric field or electromagnetic field for communication and computer engineering also. Instrumentation engineering. Okay. Design of sensor, data acquisition equipment. Yes. Okay. So many fields about electrical engineering, many utilization. So for mechanical engineering and polymer engineering, so you need to know some about this also. So you face things about it, how to use the sensor, how it works, right? How the sensor work, how the communication system work, how the motor work, like this, how much for the electricity consumption for your equipment, right? For the machine, like this. Okay. Okay, now let's come to some basic concept of electricity. Just remind your knowledge on physics, right? We talk about electricity, charge, current, voltage, power, and energy, right? This is the physical phenomenon arising from existence or interaction of electric charge, right? The electricity is take place when the charge is there. In fact, the electron moving, right? The electron move, we will get electricity, right? And where can we observe, experience, use the charge? You can think about that. Where we can observe the use of the charge. In your life, is electricity, right? But we cannot. Electricity is there, but we cannot see. Okay, we can see the light. We can see the movement of the fan, right? But we cannot see the electricity in fact. Okay, but if you touch it, you can feel it, right? Feel it. Okay. And this is the about of electron charge. We may have electron and proton. This is in this class we not compute about this. It's not like physics, but we will use the engineering term. We focus on engineering term, not physics term of the phenomenon, right? This is the electron charge in Coulomb, right? And the charge particle exhibit the force. The negative charge will take the force to each other, right? And the opposite charge will attach one another, right? Like this. And this is the force in between the charge. Here is it from the Newton law, right? K Q1 Q2 divided by the distance square, right? Okay. And this phenomenon can result from moving electron in the conductive material, moving ion on charged solution. This is the basic that make us get electricity, get the current, because the charge is moved. When the charge is moving, right, we will consider the positive charge move in the opposite term, and the current is the Coulomb per second. We call Coulomb per second as ampere, right? This is the electric current in terms of ampere. It's 1 Coulomb moving in 1 second, right? We call 1 ampere. Yeah. Okay. And in the electric circuit is the interconnection of electrical elements linked together in closed path. In the use of electric, we need a closed path like this, or we call this or circuit, right? For example, the electron or the electricity can flow only in the closed path like this. If you have battery, you do lamp bulb, and the circuit is not closed, the electricity cannot flow, right? It can flow only in the closed circuit. If the circuit is not complete, current is not there. The current can flow only. There is a path for them. Okay, you have the path for them only. Okay. So, to analyze the electric circuit, we need to define the direction. Okay, if the current flow from A to B is I1, the current flow here we denote it as I1, and the current from B to A is I2. It will be the same amount but in the opposite direction. In terms of mathematics, if the current from A to B is 5 amp, I from A to B, it means that the current from B to A is minus 5 amp. Okay, so we define the direction by mathematical sign. Okay, so if I say that the current flow from B to A is minus 5 amp, this means 5 amp in opposite direction. Okay, this means the same amount but opposite direction. Yes. Okay. This is the DC current. But for AC current, alternating current, the current will flow in this shape, right? Will flow in 2 directions. The current will flow from A and B. For example, the current will flow both directions together. And the direction of AC circuit will denote by the phase shift of this curve. It is denoted by current and voltage phase shift. For example, if we have bulb like this, and the current maybe phase shift is not in phase. Voltage and current is not the same phase. Okay, here we define the direction of AC current by phase shifting. So to analyze the AC system is more complex. Okay, to DC system. Okay. we start with DC system first, right? When we analyze AC system, you will feel some difficulty in solving AC system, alternating current. And for the voltage, also we define the same mathematical term. The voltage between A and B is VAB. If we say the voltage from B to A is also the minus of VAB. And in the circuit, the voltage is often denote the relation to ground. What is the relation to ground? So if we have the circuit, for example, so this is 5 volt, this is 5 volt, this is 1 ohm, 2 ohm, 2 ohm. If we take one node as reference, for example, this is the reference node. This reference node is maybe uses as reference ground here. So this node will use as reference or 0 volt. We take this node at 0 volt or relative to ground, and this is VA, right? For example, this is VA. This node will have VA. This node will have VB. This means what? VA means the voltage between this node to ground. So VA would be 5 volt, for example. Yeah. Okay. And VB is the relation between node B to ground also. Yeah. And the voltage across 2 ohm here. If we denote this is positive side, this will be VA minus VB. This will be VAB. That is VA minus VB. So VA means the voltage related to ground at node A. VB is related to ground also. Okay, we talk about this later. Okay, into detail when you analyze the circuit. Okay, and for the voltage phenomenon is take place by the work of energy required for moving a unit of positive charge. Yeah. It's a joule per coulomb we call 1 mole. Okay, 1 joule per 1 coulomb. To move 1 coulomb we call 1 mole. Okay. For power in electric system is the joule per second in watt term, right? So the power is the product of current and voltage. P is I in 2E, and the unit is watt, right? In physics term is 1 joule of energy or used in 1 second. It's joule per second. So we can use this formula and this formula, right? I is Q by T into this formula. P is I multiplied with B into V. Okay, this is the circuit. The above photo is actual circuit, and the below photo is the equivalent circuit, right? Model the symbol into the symbol, right? So this is the battery here. This is the battery, right? And this is a switch, right? Here is a switch. Push on this switch on. This is the lamp bulb here. This when we analyze the circuit, so we analyze the symbol here, right? The battery is the volt of battery, right? And this is a switch and the lamp bulb. We can transfer into resistance, right? In how many ohm of the resistance? So we can solve this circuit, right? If we know the resistance of the lamp, we can compute the current, right? If we measure the current, we can compute the resistance of the lamp also, right? So write this knowledge. Okay. This is the circuit element here. We use in this class also. First, we may use DC voltage source here, and this is resistance, inductance, capacitor, right? This is first pass of us, and this is diode. And in this part, this is the digital circuit. We will learn about this symbol maybe after midterm. Okay, this is the physical of resistor. This is the resistor that you will use in the laboratory, right? Okay, in laboratory, and this is each resistor will have its resistance. Okay, the resistance of the resistor, this type of resistor can read from the current bar in the body, right? In resistance. So you will learn how to read the resistance value, okay, in the laboratory. Okay, here. This is the table of reading, right? First band, what mean the first band? Second band, third band, and the fourth band. Okay? And this is the accuracy. The last band is accuracy. Okay, silver is plus minus 10%, the gold is plus minus 5%. Okay, you will use this resistor in laboratory. Okay, maybe tomorrow, right? I don't know. Okay, this is how to read the resistor. Okay, and for the resistance, mostly we will use Ohm laws, right? It depends on the material property here. Low is the resistivity, right? Low. And the resistance is low into L by A. So the A is the cross-section area. L is the range, right? L. And the property is low. So the resistance of the material is R is rho L by A. So it's depend, the resistance of material is depend on the cross-section area. If the cross-section area is large, the resistance become lower. If the length is long, right, the resistance is larger, right? It's larger. And it depends also the property of the material, right? The resistivity, right? And if you use copper, you will get this very low resistance. If you use aluminum, it's low resistance, for example. It depends on the material. Yes. and the relation between voltage and current across the resistance is V into R. V equal to R into I. This is the relation. V. This is I and this is V. If you supply the higher voltage, you will get the higher current, but in linear form, and the slope is R, right? If you increase the voltage, the current increase, right? In linear relation. If you increase the current, the voltage also increase in linear term. With the slope of with we call this as Ohm's laws, right? And we also have another two types of main circuit equipment. First is capacitor, and second is inductor. Inductor, like this. The capacitor is the storage device. It can store the charge in between the surface here. So this is a symbol of capacitor. This is a capacitor, right? And in the circuit, we use this symbol. It can store the charge in the surface. So the capacitor, once we supply when we first supply the voltage across the capacitor, when we switch this, the current will flow, but it cannot flow past this capacitor. So what happens when the current flow? When the current flow, it shows the positive charge here and the negative charge here. When you supply voltage to the capacitor, when you switch on, the current will flow. But if you charge the capacitor into full capacity, and the current cannot flow anymore, okay, after full. And what happened? So this is the current, this is the time, and current will stay down into zero. Okay, current, right? If you measure the current here, first we switch on the circuit, the current will flow, and the charge becomes stored in the capacitor. And comparing to the voltage across capacitor, when you switch on, first before you switch on, the voltage is zero, right? Okay. When you close this circuit, the voltage increase into some value, into full charge. Get into the full charge, and then the voltage not increase anymore, right? And the current becomes zero, right? Okay. So first vision, the current flow is staying, but after that, after some time, it's become open circuit, right? Become open circuit, and the voltage VC is, this is V battery, so VC in equal to V of the battery. Okay. This is a transient phenomenon, right? This will work only use take switching. So if you take the circuit like this, if I say that this circuit is connect with this condition for a long time, what happened to this circuit? The current is zero, right? The capacitor will act as open circuit, okay, in DC system. Okay, without any change. If you don't change anything, it's become open circuit because it's full charge, right? You get full charge. But the energy are already stored in capacitor. So it's one of the storage device. Okay, it's storage device. Charge the voltage to the in between the surface, right? Oh, okay. And this is the property of the capacitor, right? This is a charging condition. If you connect, it will get into initial is uncharged. After that, it get a full charge, and the current is zero, right? And the voltage equal to the voltage of battery, right? Okay. So the capacitance is of the capacitor is depend on the permeability, the area, and the distance, right? The area A here and the distance D between here. For electric property, the capacitance is equal to Coulomb per volt. This is we call the Coulomb per volt unit as Farads. So each capacitor have the unit of Farad here. Okay. So I think this I have already explained, but we can guess what happened to the lamp bulb for this circuit for initial connect. If we connect this circuit at the beginning of the connection, what happened to the bulb? The bulb will turn off, right? And then it's become slow, right? It's become turned off, right? Slowly. When the capacitor is fully charged, right? When fully charged, it's become open circuit. For the energy stored in the capacitor, we can use this formula. What equal to 1 by 2 CV square. After which there is some charge in the capacitor. This is the storage energy in the capacitor. And another device known as inductor. Inductor is in the coil. The inductor stores energy in terms of electromagnetic field. Electromagnetic field, like this. Here. It's not in the charge form, but it's in the electromagnetic form. Here. From field. Henry. And the property of the inductor we call inductance. It is depending on the permeability of its space and some coefficient, number of turn, and cross-section area, and the range of the coil. Okay. The relation between voltage and current for the inductance is depend on the for the inductor is depend on its inductance or L. V is L di by dt. So di by dt means that if the current is changed, the voltage is there. If the current is not changed, there is no voltage. Okay. Yeah. Yeah. For example, if we move the magnetic field to the coil, it produces the voltage. Or we can use coil to produce the magnetic field also. Then we can produce the voltage also. Or if we can switch on and off this change in current to produce the voltage also. So for the magnetic field like this, when we start connect first, the current will flow is there and the voltage is there until sometime it becomes short circuit. So the current at the beginning is when you start switching here, it's become short circuit like this. And for the voltage, first it's become in opposite to capacitor. So when you first switching, the voltage is there and the voltage become declared to zero and the current some value. So it's become short circuit. After long time, if you connect after long time, it's equivalent to short circuit. For example, this circuit, when we start close this switch, what happened? When we close this switch, the current is flow in two ways and the lamp will turn on. After long time, it's become short circuit, right? It's showing full energy here, it's become short circuit. The lamp bulb will turn off, right? Because the current will flow in short circuit direction, right? Yes. So when we close the switch, the lamp will turn on, and then it's become turn off after some time, automatically. Okay, with this circuit. Okay, the energy storage in the inductor is Li squared. Okay. And we use many type of many theory in many type of equipment like transformer, alternator, voltage conversion, current generator. We use this property. Okay. Next time I will talk about electrical source. Okay, and right now we remind again about R and L and C and V and I. Okay, this is the relation that we will use in circuit analysis. We have the equipment R, L, and C. Okay, this is the inductor capacitor. So first we will analyze only this is the first, and it's known as in the steady state circuit. If you connect into circuit, if you have the circuit, for example, like this, like this, in DC circuit, after a long time, it's become. What happened to capacitor? Open circuit, right? What happened to inductor? short circuit, right? Short circuit. This is the circuit. After we connect capacitor and inductor for a long time, right? Capacitor become open circuit, inductor become short circuit. We can get this circuit. Okay. But if this circuit have some transient phenomena, have something change, right? We switching, or if the voltage is not constant, it will interact, right, to the signal. So first we saw only pure resistive circuit first. Okay, maybe next time we can get into some calculation. And next is some transient circuit, which is a more complex AC circuit later. Okay, I think it's okay for today. Yes, the time is up already. Okay, see you on next week, 8 o'clock. 8 o'clock. Okay. No homework for today. It's good.